started here. I am the principal data architect for 3Cloud, one of a few. I began my career at Kennedy Space Center as part of the shuttle program some years ago. As time went on, I eventually became a techie about 1990 and been consulting for many years. Until recently, we had a PASS organization, and I spoke quite often at PASS, as particularly, at SQL Saturday, where we'd have community involvement and everybody getting together as part of the community, teaching new people and enjoying that. As a hobby, I really like small computers. Raspberry Pi is at the top of that list, just because they're little and they're doggone it, they're fun. So we're going to talk about modern data warehouse. And so at least from my perspective, what's going on with a lot of people is they're a little bit overwhelmed about the sheer velocity and size and amount of data that's coming at them. It's easy to feel like she does, I'm sure. So what this next slide shows you is just kind of that very same thing. You know, we want to know what happened in the past or what's happening now, what we think is going to happen. And the amount of data that we're receiving is phenomenal. And, you know, for machine learning, we talked a little bit about that here in one of our questions coming in. We need to know what's happened in the past to be able to piece together a story of what's going to happen, right? And so it's very important. So as we go through this, we're going to talk about some of the other kinds of data we have coming into us as well. Things that we didn't really used to see as much as data. We thought of them as assets for sure, but we weren't necessarily looking at them as part of the data sphere as much. And that's kind of what some of this area is about. And then we also have a lot of real-time data today, like IoT and all that, where we're actually reading data from sensors, like from cars to shopping. I don't know if you've been to Walmart lately or Target, but both those companies seem to use a lot of IoT in their operations from an outside perspective. And definitely use it as a way to, you know, not only monitor shoppers for shoplifting, but also figure out what it is that people are considering, right? There's been several, I know Microsoft releases on that. You know, they have a retail store up there in Redmond and a mock one to show you exactly what consumers do, you know, what the behaviors are they're monitoring and trying to figure out. Hey, they stood in front of the shelf and looked for, you know, 4 seconds, which is a lot longer than normal for most people. So anyway, those are the kinds of data that we're dealing with at this point. This growth in data is phenomenal. It really is. Look just between 2017 and today in 2021, it's over doubled, more like tripled. So we're storing a lot of data that we never did. We're accumulating a lot of data we never did. It's so storage itself is part of this story, right? And we'll talk a little bit about that, because if you're currently on premises and all you're in your own data center, you're dealing with the usual things that come with that, which is traditional SAN storage, right? For those of you who are familiar with what I'm talking about here, you know, you're buying entire trays at a time of disks to add to the existing collection of disks in a big appliance. Think of it that way. And those trays of disks are oftentimes very expensive for good reason. They're high velocity, high performance, and usually they're pretty good. So, but they cost a lot. So when you go to store this much data, it starts to be an issue because of things like lead times and whatnot. You know, we kind of get into these problems of anytime we're buying hardware, it's, you know, 6 weeks to get a new server, and then there's the time to actually configure it, rack and stack it is what we used to call it, and test it, you can spend 3 months just getting a new server online or a new tray of disks online or anything. So that's where, cloud, there's a definite benefit in cloud over that. So we're going to talk a little bit about why you need a modern data warehouse, and part of that answer, of course, is around all that data. So if you have a data warehouse today, it kind of looks like this picture a little bit. If it hasn't grown or changed at all, we've got your various data sets like your financial services system, CRM. For manufacturing, you might have an MRP system, or maybe your own custom software over there on the left-hand side. And they're being staged with the extract, transform, and load system you see in the blue box sort of in the middle. And that process will usually load the data warehouse, at least in a staging way, and eventually it'll load it all the way to the finished tables. And for that same data, it'll pull the data from the data warehouse and actually populate, an OLAP cube. For people who are not familiar with OLAP, it's a older technology, but it's very powerful. It's not like the traditional database that we think of. It's not organized the same, and the purpose is not the same. The purpose is to quickly do analysis. So it's an interesting piece of technology that's still around and still in use. And as you see, as we're going from left to right, we're kind of doing this sort of gather stage that we call it, where the ETL is done, and then the model sort of phase, model and analyze, if you will, where the little gray cube is. And then I've got Excel down there as well, because you can do quite a bit of analysis with Excel as well. And then finally, on the output, where we're going to share the data, you can see over there that we've got a report coming out of a printer, I think, and got it's probably green bar, right? That's really an old printer. And then we've got Excel and of course SharePoint as well. Ways to share that same data. And those kind of data warehouses, when they started, I guess 25 years ago, the primary thing was businesses wanted to know where are we at as far as maybe financial side, cash flow, orders received, could be any of those kind of measurements that the business needs. And so they've gathered all these pieces from all these systems and bring them into a data warehouse and then point reports at it. When the world started at this, we were on mainframes and everybody used the reporting mechanism within a mainframe. So there was no data warehouse like this. So that was kind of the V1. So this new kind of approach, we're talking about what makes it modern, right? So it's cloud-based for one. It's not on premises. It's not living in your data center. It's in the cloud, and for us, it's in Azure, right? Because that's our world. We have more types of data, as we mentioned in the beginning. The structured and semi-structured and unstructured data. We'll kind of talk about that a little bit more. What do those things mean? But we also have things like AI and machine learning, where we can use artificial intelligence to figure out and forecast and identify patterns that we haven't noticed. So it becomes an important piece of the modern data warehouse is the ability to do machine learning. Now, sometimes we do the machine learning piece in one of several tools. We may use Spark, which we'll get into, and maybe we'll do Azure machine learning, which is another piece. So a lot we can do there. And the other part, a couple of the other ones, is that it's very scalable, right? So the beauty of the cloud is I'm not locked into whatever walls that the hardware are locked into. If you buy a server and it's got 4 processors in it, it's physical. It'll always have 4 processors in it. There's no such thing as scaling in that way that we are used to in the cloud, where we move a 100 a switch and suddenly it's got 20 processors. And then when we don't need 20 processors, we can scale it back down to 4. So we pay for what we use, and that's a fundamental principle there. So in that way, it's very flexible, right? So it gives us a chance to make a mistake. I've seen companies buy all the hardware and staff up for a big project. There's no joke, and have like 20 odd servers sitting there and having somebody put it together and do all the stuff I mentioned earlier and get it racked and everything, and it sits there. And I come and buy the data center and say, "What are all those?" And they're like, "Oh yeah, it's for project whatever it was." And I go, "Oh, okay." So 3 months later, I'm back in their data center and said, "Well, how's project whatever is going?" We haven't started yet. There were some problems with the concept, and we haven't done it. So literally 2 years later, I'm still asking that question, and nothing has been done because now the projects have been canceled. So now they're eating the cost of those servers, and because of whatever restriction they had, they decided to just let them sit there until they had another big project. And by the end of 5 years, I'm still talking to some of the people, and it never got used. So that's the kind of problems that we used to get into, not specifically that one. That was kind of a weird one. But the fact is that you had to commit to what you're going to do. And so you had to have a pretty solid plan. And even then, sometimes things didn't work out. So being in the cloud erases all that problem. We can stand up something quickly and we can tear it down quickly. It kind of gives us that flexibility. All right. So I want to talk a little bit about this approach, right? We've got two ways to look at information management, right? The top-down and the bottom-up approach, right? So on the left-hand side, we have this deductive method, right? Where we start with theory, we generate a hypothesis, we do observation, confirmation, and so we start from that perspective. On the other hand, when we do it from the other perspective, from the bottom up, we actually start with observations and then develop a pattern and then the hypothesis and then the theory. And you can see by this line here in the middle, what happened, why did it happen, all that. It starts to build the case. And the reason that this is in here is because there are two separate ways to think of a problem like this. And typically, your data warehouse is on the left, on the top-down side, where we're, having to go at it from that perspective first, versus a data lake, which is the opposite. And we'll see that here shortly. So here's your top-down approach. We go and talk to corporate strategists and all the decision makers, right? And we talk about business requirements and technical requirements. We do all those good steps. And then we go through and do the analytics design and figure out what we're going to try for. Do dimensional modeling, which is part of this whole thing. Looks like this one area is a little hard to see. The next one down says ETL design. And then next over from it is ETL development. Sorry for that, I missed that. So we go through this sort of process using this top-down approach, and eventually we end up on the right-hand side with sort of this BI and analytics piece where we have dashboards and reporting, and we've got our data warehouse and our little ETL process working, and it's all just great. So when we talk about using the data lake, we go the opposite way, right? So we take in, if you'll notice on the left-hand side, we have devices and social, that's a little tweet bird there, line of business applications and video and web and sensors for IoT and Internet of Things, if you don't know what that acronym means, relational databases and then clickstream. And then we go through and do the ingestion straight to the lake, right? We kind of go at it with a store all data. We don't try to change anything immediately, and then we'll work from there. I'm going to go on from do the analysis. That thing is also weak. We do the analysis piece after the fact. We do the batch queries, interactive queries after it's all been stored. And then eventually it ends up in a data warehouse. Do we have any questions yet, Crystal? Is anybody asking anything, or everybody with me?
Everybody's still with you, so we don't have any questions just yet. I know that the PDF, guys, is not working, so I am getting that fixed up. But other than that, just continue on, because I think most questions are about the PDF. I am trying to get the PDF fixed for the PowerPoint.
Okay, all right. So this is modern data warehouse, and it's vastly different from the earlier diagram you saw of data warehousing, right? It doesn't look at anything sort of, I guess vaguely it does look like that, but you see on the left-hand side, we have all these different data sources, right? As we mentioned, coming in from Twitter and REST APIs, and could be pictures and movies, and it could be PDFs, and then the things you would expect from the old days, right? Databases and maybe extracts from third-party vendors or stuff like that. At the very bottom is an IoT hub, which we'll talk about in a second. But we're coming in with ETL, and we're doing that gather phase, right? We're using Azure Data Factory as our ETL solution, and we're using Data Factory's pipeline facility and bringing that into Azure Data Lake. We have Azure Data Lake Store V2 is just really just fantastic storage is what it is. For those of us who've worked around Hadoop a while, it looks somewhat familiar because it looks a lot like the store that we would see with Hadoop's file system, HDFS. It's hierarchical, it follows the same POSIX constructs on security, some very, very close similarities. The great thing is it doesn't cost like Hadoop could cost, and it's not physical hardware sitting in your data center. We also have in that same store area, we have, I'm showing Azure SQL Database, but it could be lots of different data stores as far as the database. And then on the very bottom, let's talk through the IoT chain here. I'm going to try something here. I'm not sure it's working today, but I'm going to give it a try. My computer's been giving me trouble today. No, that's not what I wanted. Let's go back here. Yeah, that's what I wanted. All right. If we go from here, from the IoT hub and then through streaming analytics, streaming analytics, what it is we'll start with IoT hub. It's really, I think of it as a queuing sort of mechanism. People can have, sometimes hundreds of sensors tied to the same hub. And streaming analytics is nothing more really than a job that reads that hub and pulls the data out. And it can pull it out and do the same data multiple places. And that's kind of what's being shown here, where we have, it's going to the data lake at the same time as it's going to over to Cosmos DB. And you can actually, as you can see on the diagram, you can go straight to Power BI with it. Obviously you set up a streaming data set and then point your streaming analytics job at it. By the way, it works great. I've used it a bunch and really like that. Let's keep doing this. Let me see. Oh. All right. Let's see. Let's see if we can get it to go back where I am. There it goes. All right. There's more than one kind of Power BI, as you see on the right-hand side. We have embedded, we have the service that's being shown here, and there's also Power BI desktop where you do usually all your authoring. And so that kind of talks that. Azure ML is another piece of this. I mean, you could be using machine learning, and if you did, you could be going about it that way. One of the more popular projects I've done of late is taking some of the cognitive services like Azure Search and actually using it for what we think of as data mining, where we go through like a giant repository of PDFs and Excel spreadsheets and unstructured documents and whatnot, and use that to provide intelligence. In addition, we could be using Databricks, which is the red sort of icon there in the middle. Databricks is Spark, came from the Apache, is an open source data consortium, and they're great. The Apache folks have brought us many wonderful projects over time. Hadoop was one, Spark is another. And if you go out and actually go to the apache.org website, you'll see there's so many and great ideas. So Spark, the Databricks part of it is just Apache Spark, but it's also a little different than most Spark implementations because it's in the cloud. You can't like download Databricks and put it on something, as far as I know. It's purely in the cloud. We'll go a little further. We'll talk about Synapse Analytics, which we're going to get deeper in. A lot of times we can use that part of Spark is available in Synapse Analytics for that purpose. You could also use it as a place to store, so it could be in the same category as Azure SQL Database. It's a very flexible tool, it has a lot of capability. The last piece is Azure Analysis Services. If you think back to the cube I showed you earlier, OLAP is as long a tooth these days. I think we've had it in SQL Server now since 1996. It was bought as a third-party product and brought over from Israel, if I remember right. And eventually it became part of the SQL Server landscape. But it's also done by other vendors as well. Essbase is one I can think of. Fast forward to today, we're really focused on tabular model today. Some of the problems with the old OLAP stuff is the barrier to entry was really high. You had to really spend a lot of hours and get a lot of help learning how to use it, how to understand MDX, and how to use that's a complete query language for that platform. And so we've now working in the world of tabular, which is very familiar because it looks a lot like tables in a database. It's got that same kind of relational feel. It's fairly easy to understand. And DAX, which is the equivalent of MDX, is pretty doable. It's pretty understandable for most people. And the other part to know is that Power BI itself is built on that technology. You can literally connect to a report as if it were an instance of analysis services in Azure. Very cool stuff. So the last phase, we talked about that a little bit earlier. We're going through SharePoint. We can surface it in SharePoint or Excel or Power BI, whatever you choose. So that's kind of the biggest part of modern data warehouse are those things. We'll move on a little bit. So we're going to kind of go into these data types, right? You've heard me say unstructured, semi-structured, structured. Then this is what they are, right? So years ago, we didn't even talk about audio and video and images and stuff to be, actually treated as data. They were artifacts, but we didn't worry about trying to do anything with them. Now we do. We used predominantly for, things like I mentioned, machine learning or some kind of data discovery piece. For the semi-structured, you'll have everything. You'll have JSON data, XML, sensors, social media, device data, all of those kinds of things. And then of course we have the traditional structured data, which we data people tend to think of like, columns and rows and that type of thing. So in that sort of semi-structured area is also receipt data, like, business people out on trips and buying dinner and stuff. But we've got some great tools inside of some of our cognitive services to actually be able to go out not only read receipts, but actually read forms and like that with AI, and pull the data off of those things. So it's pretty, it's actually pretty neat, and handwriting as well from them. So that's part of what we're talking about today. I was going to stand up a Synapse Analytics cluster. Let me see. I'm make sure I've got enough power to do that. I'm having some issues here in Houston with a cold, so bear with me. So if you have worked with Azure before, you'll recognize this is the portal. This is what you get when you come in. And so when you come in here, you can work with this and create a variety of assets. I'm just going to go through, rather than try to create a lot of this, I'm going to show you, since we don't have a lot of time. This is what the storage itself, which we keep talking about, data lake storage and what does it look like. And so this is just, what you would normally see. And if I pull up Azure Storage Explorer, this is not a free tool you can use if you haven't. You can start to get a sense for the fact that it is storage, right? So I'm going to go to my own Visual Studio subscription here. I've got a storage account here that I'm using. And then we go through, after it loads for a second. I'm running on a hotspot because of power outage, so if it's a little slow, I'm sorry. Got a container here. And so now you can see it's starting to look familiar, right? Here's a bank churn piece I was starting work on. Here's a Central Park census for squirrels, believe it or not. It's one of my favorites. I play with this pretty often. If you're not familiar too, one of the things I do is I go to different data sources that help me explore and try things. Like Kaggle is one of those places, but also like New York City. Here, we'll go to the New York City open data area. New York City makes all of its data open, so you can actually go out here and see all kinds of things. And here's the squirrel census that I'm playing with. So just so you know that, one way to learn if you're interested in trying things out is a great way to go out here and play around. They've added a lot to this too in the last few months, and they actually show you the details on this. I like squirrels as much as anybody, but I just thought it was a fun, harmless piece of data that I could share with you. All right. So anyway, back to the portal. We can go through here, and you can see, how much has been moved around inside the data since the time it's been on, and all that sort of thing. And after a little bit, I'm going to ask you how much you think the storage costs people, right? And show you where to look. Because I think that's an important part of your decision process, is not only can you do it, but how much is it going to be? And I find more and more that people don't go out and look, and I'm going to help you with that. Regardless, let's see. I created a workspace for Synapse Analytics. When you create one, you get something called a pool, right? There's I'm looking down here at the moment. There's a built-in pool that's created when you create a workspace. We're going to play with that for a minute and then get back to our regular scheduled presentation. But the cool thing about that is I can go in there and actually use it without having to create. Think of the pool as more or less a database, right? It's not quite one for one because of some reasons I won't go into, but it actually gives you kind of at least a place to start, So if I open Synapse Studio itself, I get this experience. right? And because it has a working pool at the moment, which we'll show you the other option, I can go ahead and do things like play around. So this is the experience we have, right? So and through here, as we go through, you can see where we have like ingest and explore and analyze. It'll basically take you through the steps. Visualization, because it's tied into Power BI, or can be, as one of the linked services. It's pretty neat. And then there's a whole learning center that you can go through. So if you can, try to get, if you don't have experience with Azure and you don't have any hands-on stuff, try to get an inexpensive or free subscription, and that they give you trials, I think, that you can try out and drive it around. Anyway, so here we are at home. We can actually be down in this sort of data area, and if I had databases attached and that sort of thing, I could do that and include it. And same thing with integration. If you've ever worked with Data Factory, you'll kind of recognize this interface. It looks very familiar. We could go back to the develop interface. Now, what I'm doing up here is I'm clicking this plus sign, and it will let me create a new SQL script or a new notebook, if you're familiar with those, new job, definition in Spark. I'm going to just browse the gallery. There's a whole gallery of stuff that you can go play with, and I encourage you to do that. And so you can come in here and there was read and write data to the storage. Oh yeah, we can actually play with this PySpark sample. See, it's running down here. We can open this and actually have it. So it's asking me. You'll notice up here it's warning me. Okay, so be sure you have this contributor role. Okay, how do I know if I've got the contributor role? So let's see. Let's go back to my storage, and we'll go here. This is my storage, and so if I go to access control, I can click on this and see view my access, and you can see I'm in the contributor role. So yes, so I do. So as we go through, let's see, where'd it go? I'll try it again. All right, we know that's true. Tag, column projection, Spark table. And it will take you through what it's going to do and how it's going to work. So you can go over here and you can go cell by cell and load the data just as if you had done all this work yourself. But it kind of gives you, a preview of what's going to happen. So if I open the notebook down here below, it's going to want an Apache Spark pool to run this. And because this is on a really cheap subscription, I probably don't have the money to do it. But basically, this is where you can create a temporary Spark pool and go out and then play in the data and throw it around a little bit. So anyway, I hope that helps a little bit. It kind of gets you thinking about driving around trying this out, because it's actually pretty cool. All right, let's go back our presentation. So we got a sense of how to use it right there, right? We're starting to talk about using Spark pools and pulling it into storage and using it, right? So for Data Lake, I'm happy to move something here. Here we go. So what is a data lake, right? It's this just piece of storage that I mentioned, right? I would place a landing place for that. And there can be lots of best practices and such, and we're going to talk a little bit about that. But that's what it is. It's a piece of storage to land your data in. And most of all, I always think of it as immutable, at least in the first stage, because what I want is a copy of the data in its native format. I don't want it changed. I don't want it anything. I just want a copy put out there. I may, then there are reasons, maybe I need to be able to have that place from, that the IRS is going to audit, and the data has to be native. It can't be ever changed. Maybe that's where I store it, because here it is, years later. I don't want it in my big database. I wanted it stored out on storage. So I don't want that first step, that raw step, messed with. And then later on, and through other what we think of as zones, you'll see that we do make changes. All right. So Gen 2, fantastic stuff. We had a Gen 1 product that was really kind of built differently, different architecture, different approach. Microsoft went back at it and did a fantastic job in creating V2 of this stuff by really leveraging what they do well. And one of the things they do very well is blob storage. So they improved on that. They added a lot of features to it. And of course, with that, it also brought the price down. They're no longer, big servers sitting on top of it and things like that. So fantastic. So here are your typical landing zones. I mentioned raw a minute ago, but each of these has a purpose, and none of them are hardcore, got to have, except for the raw one. The rest of them are kind of up to you on how you want to divvy this up. I've even seen customers that have separate storage accounts for these different purposes. They don't want to mix things together. And so raw goes on one storage account, and curated goes on another. It also lets them control security differently. So sometimes those are good things too. But you've got, particularly analytics, you've got your own separate storage place for that. And oftentimes that analytics store is where people will do machine learning. And then, sandbox for people who are just learning, wanting to play, and you don't want them to get outside the sandbox and damage anything. So anyway, just an idea. So a lot of people get into this quandary, like, do I want a data warehouse or a data lake? Well, you need both, to be honest. One provides some functions in a modern data warehouse, and the other provides the other function. So as you can see here, the requirements are very different. The data values are different. Everything is different between the two. And modern approach is to have both. Here's an example of a design, a typical file structure you would see in even Windows or Linux. It's hierarchical in nature. You'll see a lot of times when we're pulling data and using, like, say, Data Factory, it'll natively store things correctly in that sort of hierarchical structure. So in summary, schema on read versus schema on write. We hear that a lot, and now, hopefully this has helped you start to see why. Basically, one, we're copying files around, and the other one, we're actually inserting rows and tables and whatnot. So they're very different things and work differently. So ingest, store, and use. That's our game, and that's what most people do. Redundancy piece is really important as well. Locally redundant storage, LRS up there, is 11 nines. Think about that. That's phenomenal of having that kind of high availability. And then, ZRS is up to 12, and then 16 nines for the other two on the right, which is GRS, RA, GRS, and so forth. So, sorry. So that is phenomenal, having that capability of not losing data and being able to depend on it being out there. The great thing about blob storage, you pay for what you use, right? And having such high availability is a huge piece as well. There are many others. I mean, being able to stand up a storage account quickly, I can do it in less than, well, if I did it in script, I could do it in seconds. So it's literally that fast. Security is really good. You know, you've got your network security groups to control networks and who gets to what, firewalls, Azure Active Directory. Hopefully you're using that to control who, you know, authorization and all that. RBAC controls. And also the encryption piece is huge. If you are working in an industry where you need to have data encrypted at rest, this is fantastic. 256-bit AES is as good as anybody does. And you can actually double encrypt it if you want. And you can encrypt it with your own key and not our key, or not Microsoft. I used to work for Microsoft, so I still think that way. Let's see. And on compute, you know, Synapse Analytics, you know, some of its best feature set is the fact that you get what you need to get as you need to get it, and then can dial it back down. So it's all pretty much on demand and fully featured. I like the fact that storage and compute are separate. I can grow the storage separate from the compute, or I can grow the compute separate from the storage, either one. So it's phenomenal. I think for my part, this has been the biggest win for Microsoft in this product. I really think it has a huge place, but I also like many other pieces of the data platform, such as Azure SQL Data, Database, and then our normal Spark clusters. So the architecture between Synapse is different from the servers of your. It is actually an MPP device, and massive parallel processing is basically what that stands for. So you see each of these little databases down below. They are part of our Azure's fabric, but if we would have thought of these in the old days as really as servers, right? So like in Hadoop, we would have had 60 servers, and that's how many distributions there are inside of Synapse, up to that many, depending on how high you have the slider set. So that's phenomenal, but it also introduces problems because you have to have some really big data to use it and get a lot from it. So you just kind of have to experiment a little bit. All right, and this, I just talked about, the fact that we've got up to 60 distributions out there. This is how tables are divided up, round robin distributions, where they basically evenly distribute the data across all of, we'll call them servers, but they're not. Hash distribution, basically, let you use a key to kind of divide the data and shard it across all those distributions, and then replicate it where it makes a full copy. Or if you're joining, a small lookup table, you're going to want it close to the data. You're not going to want to have it distributed across all those nodes. So that's kind of what the idea is there. Polybase is another huge piece of this. Explore the data without having to look at it, do something with it. I like the idea of being able to quickly explore data. And not, so you can land the data itself in Azure Data Lake Store, and then use Polybase to literally, what we do, what I call data virtualization, where we treat it as a table. We can see it as a table. Then we can choose to either ingest it all the way and pull it in, which is the best practice of the way to load Synapse, or we can just leave it where it is and just, maybe we don't need to bring it on board. So we're kind of running out of time, so I'm having to pick up the pace a little bit. And of course, we've talked about Spark a little bit. Databricks and Microsoft have been cooperative for a long time in Spark. And Microsoft uses both. It uses Apache now more than it does Databricks, but it still uses, from what I know. I'll kind of skip through this because I know we're kind of running out of time. One piece of a suggestion I might give you is get comfortable using notebooks, particularly Python is what I like. But as you can see down here on the left, there are a multitude of languages supported here. Scala is probably the most native language in Spark, but also R, and now Python as well. So it kind of gives you an idea, and all you have to do is basically change, which interpreter is going to run. So, all right, we've kind of gone through that data factory. I think we've just got a little too much material here. Do we have any questions so far?
We have a few questions on here. I can read some of them off. Let's see. Okay, with the modern data warehouse approach, are we populating the fact table with surrogate keys the same way we did the legacy data warehouse via merge statement or SSIS lookup task? If not, how do we populate the fact table in a new way? Are there new school ETL or ELT design patterns?
That's a great question. Not that I'm aware of. I mean, the warehouses that I see are still all star schema. And to do that, whoever mentioned that is exactly right. We go through and do certain keys so we can control the relationships between the say the fact tables and the dimensions. And so, yeah, nothing has changed in any remarkable way for that. If they're looking for new ETL solutions due to speed or some such thing, Spark would be one of the ways you could do that. Anything else?
There's another question. How does data, I think they're trying to say virtualization, fit in this overview?
So data virtualization, as I mentioned, is a great way to store data in Azure Data Lake Store and then use like Polybase as a way to treat that as an external table. And external tables are really not unusual. I mean, if you think about Oracle or you think about Hive or you think about, man, a lot of products, even SQL Server these days, we have an external declaration. And what we're doing is we're saying, here's a table, here's the structure that you're going to see, and here's where it's at, here's where the data lives. So you're no longer pulling it right into a database. You're actually describing it and just using it where it is. And then if you want to, you can do a CTAS statement and pull it in. It means create table as, if you're not, for those who are at home playing along. Then you can do that to pull it into your data store if you want to. Does that make sense?
All right, next question. Let's see. I know you guys are still struggling with the PDF file. I promised to get that taken care of in the email. So just hang on to that. Some more PDF. Yes, there will be a recording at the end of the webinar. That looks like all the questions for right now.
Okay. We've got, what, 4 more minutes? Okay. Let's take the 4 minutes and drive through what we can here on Azure AI and see if we can get a little more in here. So with Azure AI, we have a lot of different offerings to work with. The cognitive services are probably the most friendly. They do the most. And actually, let me see if I can get this to behave. I'll see if I can get you through something here. See if we can locate this. This is a demo that Microsoft put together. And what it is, it relies on a lot of the pieces that we talked about here. You can go out here yourself. You don't need me for this, but the nice thing about this is that, you know, we all know that Oswald was the person that shot Kennedy. So this is a repository of all the documents that are public and that were made public by the government. And so it kind of shows you some of the advanced features. So, all right, so I just did a search on Oswald. And as you can see down in here on the right-hand side, that it's found his name. It's not very clear on my side. I don't know if it's my slow computer from my problems here, but you'll notice that it also found his name, his handwritten, is in there. Excuse me. It also found a picture of him. That all this is done with AI. So, you know, where we have these massive document stores and we want to make sense of all the data that people have, I think this is probably one of the coolest examples of how businesses can use AI to help make a difference. And the last part is it'll actually show you the relationships between things, people and things. So you can start to see how he figures in throughout all of these things that are mentioned in the documents. You know, I don't know much about these people, but and one of the funniest ones that I found one time was SQL. Let's see, because somewhere, let me go back to the other side of this. SQL Server was a platform they used in the early 1990s. So I thought it was funny. But anyway, it's a phenomenal piece of demo that you can go drive around yourself and play with it. And you can get some sense, you know, look at how handwriting recognition is being used, and look at how the vision pieces are being used, and look how Azure Search is being used. It's a nice bring together, and the code for all of it is in GitHub. So you can go download the code and have at it. All right. Well, if that's it, I don't want to keep people.
All right, thank you so much, Roland. We appreciate it. As for everybody asking about the recording, you guys will receive a recording tomorrow around noon Eastern Standard Time in your email box. I am going to try to also attach the PowerPoint PDF into that email too as well. If you guys do not receive the PowerPoint in that email and you would like to, please just feel free to reach out to me at kreyes@3cloudsolutions.com. My email address will be in the email that you guys will receive tomorrow. I hope you guys have enjoyed this webinar. I hope to see you guys next Tuesday. As for the recording, you guys can also view any of our past recordings on our YouTube channel under our free webinar playlist. Thank you guys so much again for joining. Have a good rest of your Tuesday, excuse me. And Roland, thank you so much again for hosting. We greatly appreciate it. Have a good day.
Yeah. Take care.
Bye-bye.